So now we're going to move on to our second topic for review, which is derivatives. So remember that we had a whole bunch of derivative rules. So I'm going to list some of them out now. We had the power rule. We had the product rule. We had the quotient rule. And the most difficult of all, we had the chain rule. So we're going to look at some functions and find derivatives here. So let's look at a few examples. So find the derivative of the function x cubed plus 2x minus 3. So this is a polynomial. Anytime you have a polynomial, when you're looking for a derivative, you just need to use the power rule. So remember, for the power rule, we take our power and bring it down in front. So I'll get a 3x and then reduce it by 1. So it'll become squared. Plus, and then we get the derivative of 2x is 2. And the derivative of a constant is 0. So this is my derivative, 3x squared plus 2. All right, so polynomials are the easiest types of functions you can find derivatives of. So now let's find f prime of x for the function e to the x times ln of x. So here we have a product of two functions, so I'm going to use the product rule. So f prime of x, the product rule says you take the derivative of one of them, e to the x times the second, and then you flip it. You take the first one times the derivative of the second. The derivative of e to the x is e to the x. The derivative of ln of x is 1 over x. And there's my derivative. Let's look at another example. Let's find the derivative of the function x cubed plus x minus 2 over sine x. So here we have a division or quotient, which means we need to use the quotient rule. So f prime of x, there's a formula for the quotient rule. It's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So now I got to take the derivative of this polynomial here. Just use our power rule like we did in the earlier example. So this would be 3x squared plus 1. The derivative of sine is cosine. Sine squared x. And you don't need to simplify it any more than this. There's my answer right there. All right, let's look at some more examples involving derivatives. Find the derivative of the function tangent times secant. Again, this is a product here. So to find the derivative, we could use the product rule. The derivative of the first times the second, and then flip it. The first times the derivative of the second. The derivative of tangent is secant squared. the derivative of tangent, the derivative of secant is secant times tangent. So this is secant cubed plus secant times tangent squared. And you can leave it like that. There was also another way you could have done this problem if you took your function f of x, which was tangent times secant. You could have written it in terms of sines and cosines and done it that way as well if you want. So sine over cosine, secant is 1 over cosine, sine over cosine squared. And then use the quotient rule instead of the product rule. It's up to you. That's just a different way to do it. So let's move on to our last couple of examples here. Find f prime of x for the function 3x plus 6 to the 10th. So here you do not want to simplify this function because it has such a large power here. You would have to distribute out and multiply and FOIL, and it's going to become really, really messy. So instead, you should use the quotient or the chain rule. So you're going to look at the outside, which is a power. So you're going to do the power rule first. Bring down the 10. Reduce the power by 1, so it'll become a 9. And then the chain rule says you have to multiply by the derivative of the inside. And the derivative of the inside part, that's 3x plus 6. And the derivative of that, you just have to use your power rule. The derivative of that is 3. So in total, you're getting 30, 3x plus 6 to the 9th. And that would be our answer. Let's look at some more that involve the chain rule. So find f prime of x for the function e to the 4x sine pi x. So here, again, I have two different functions being multiplied, so I'm going to have to use the product rule here. So the derivative of the first, e to the 4x, times the second, plus the first, times the derivative of the second. And then for each one of these remaining derivatives, you're going to have to use the chain rule. So the chain rule says the derivative here is e to the 4x times the derivative of 4x and then the derivative of sine is cosine times the derivative of the inside. The inside is pi x. So here we just have to take the derivative. You get 4 cosine pi x. The derivative of pi x is going to be pi. So there's my derivative. And let's look at one final example here. Find f prime of x for the function sine x cosine x minus e to the pi. So for the first one, you're going to have to use the product rule. The derivative of sine times cosine plus sine times the derivative of cosine Now notice e to the pi here, it has no x in it. It has no variable. So in the end, that's just a constant, and the derivative of a constant is 0. So here I'm getting cosine. The derivative of cosine is a minus sign, so I'm getting cosine squared minus sine squared. And that's my derivative.